So that was difference in sum of squares. Difference of cubes, a cube root is when you have a number that, when you take the cube root, you find the number that multiplies by itself 3 times to get whatever number you started with. So for example, again, we're looking at this difference word, so we're going to have subtraction between two perfect cubes. All right, x cubed is a perfect cube because x multiplied by x multiplied by x. So x 3 times multiplied by itself will make x cubed. Other cubes are 1 times 1 times 1 makes 1. In class we listed 2 times 2 times 2, right, makes 8. 3 times 3 times 3 makes 27. 4 times 4 times 4 makes 64. 5 times 5 times 5 makes 125. Any of those numbers, they're perfect cubes because I know that if I take the cube root, I will find the same number multiplied by itself 3 times to get this number that I have now. Difference of cubes is if I have 2 cubes and your formula uses a and b, so any cube, I will take the first cube root minus the second. Since I have factored out 1a already, I have an a squared left, and then plus ab. These are the opposite signs. So if I start with minus, because my problem is minus, I'm going to, my second one will be positive, and my last one is always positive. So I need to identify what is my a value for this formula, what is my b value for this formula. So for my problem, my x is going to be like a, and my b is going to be 5, because 5 times 5 times 5 makes 25, whereas x times x times x makes x cubed. So for my formula, for me to apply my formula to this problem, I'm going to do a minus b, which is going to be x minus 5. Then I take a squared, so for me that will be x squared, plus a times b, which will be 5 times x, or x times 5. So 5x is the appropriate way to write it. You always want to put your number first so you have a coefficient. And then plus b squared. My b is 5, so 5 squared is 25. Again, if I take my x minus 5 and I distribute it to all the terms in the second polynomial, and I do the same with the negative 5, I will get x cubed minus 125, which is what I should get, because that is what I should match my my original problem to. If I check myself using distribution, I should get the same answer back, because I'm just going in one full circle. A sum of cubes, the only difference is that instead of having, oops, I'll put the green down. Instead of having a cubed minus b cubed, I have a cubed plus b cubed. Everything is the same except for my signs. Because it's a sum, I'm going to start with a plus b. A sum meaning plus. Then I have a squared, opposite sign, times ab, or subtract ab. Last is always positive, b squared. Let's go ahead and put these to practice, because I have all these different formulas and I've got different ways of factoring, but when they're all mixed together, sometimes it's hard to figure out which formula I used for what. So let's do a couple examples together. I am going to look, let me get my screen here. That is easier to use now. Okay, let's look at this first one together. 3st squared minus 9s cubed t plus 6s cubed plus t. First comes first. I always want to look for a greatest common factor first. So let's see if there is a greatest common factor. My greatest common factor looks like I can pull a 3 out. So I'm going to go ahead and take 3 out of all 3 terms. It also looks like they all have an s in common, but the first term only has one s. So I can only pull one s out. And the t, there's only one t in the second term, but I can still pull it out. So 3st, that's my greatest common factor. Now I'm going to place everything that's left over. I'm going to bring this down because it's smartboard gets a little wonky when I write high up, which is fine. So 3st. Oh my goodness. Let's try that one more time. All right, I'm going to take out the GCF. 3st. Okay. What's left over is I have one t that I have not accounted for yet. I also have a 3 and I have an s squared that I have not accounted for yet. And I have a 2 because 3 times 2 makes that 6 that I need. I also need 2 more s's and I need another t. Okay? I have taken out my GCF correctly, and now I'm going to take a look at all this that's inside the parentheses. I always want to see if I can continue to factor. So when I look at this trinomial here, does it look like a trinomial that I can use reverse FOILing on, or slide and divide? Or is it a binomial? Can I do sum of squares, difference of squares, sum of cubes, difference of cubes? In this case, I can't. So this is as far as I can go, which is just taking out the GCF. Taking a look at the second one, I want to start with my greatest common factor again. Is there a greatest common factor between x squared and then 49y squared? Since the two terms are x and y, I know that they both don't have an x or a y in them. And 49 is one term, the other one is 1x squared. There's no number except for 1 that they have in common. So I don't have a GCF. So since I don't have a GCF, I'm going to go straight to, is it a trinomial or a binomial? And if you guys remember back in your notes, we had one page that we talked about 2 different ways to factor a trinomial, and then there was another page for binomials. Well, this is a binomial, and it is subtraction. So it's either a difference of squares or a difference of cubes. 49 is a perfect square, so is x squared, and so is y squared. So I'm going to use the difference of squares formula. With a difference of squares, we set up 2 binomials, and we said what is the first times first makes the first, so x times x multiplies to make the x squared, and then 7y multiplied by 7y will make the 49y squared. With difference of squares, if you look back at your example, we had 1 minus sign and 1 plus sign. Therefore, I'm going to use the same 1 minus sign and 1 plus sign. Those are my 2 factors for difference of squares. Let's take a look at x cubed plus 27. Again, I'm going to check for a greatest common factor. This does not have a greatest common factor. So I'm going to go straight to, is it a trinomial or a binomial? It is a binomial. And then what type of binomial? This one has a plus sign. So since it has a plus sign, it is a sum of something. And then I look at 27, I look at the x with the little cube on it. Since it's cubed, I'm thinking it might be a sum of cubes. If it's a sum of cubes, I have to look back at my notes. I have to think, okay, that means I have to figure out what is that a value, what's being raised to the 3rd power, and what's my b value, what's being raised to the 3rd power. Well, to make x cubed, I'm going to use x times x times x, right? To make 27, I'm going to make 3 times 3 times 3. So x plus 3 is my first factor. The second factor, if we look back at our notes, is this a squared minus ab plus b squared. So I'm going to take my a value, which is x, and square it. Minus. I want to do opposite. A times b, so 3 times x. And then my last term is 3 times 3, because it's my b value squared. Remember our hint in class was that these signs are always same, opposite, and positive. My first sign is positive because it's the same as what my problem was. So since my problem was plus, my first factor has a plus in it. Opposite, meaning it's opposite what I started with. So if I start with plus, my second one is opposite, minus, and then the last one is always positive. SOP, S-O-P, will help you guys remember your signs correctly. Let's take a look at this one. 8a squared plus 2a minus 6. Again, I'm going to check for a greatest common factor first. Is there a factor that is common between 8, 2, and 6? There is. They are all divisible by 2. And 2 is the largest because, well, that 2 in the middle. I can't take any other number bigger than 2 out of 2a. So I'm going to take 2. I'm going to factor the 2 out, and what I have left is 4a squared plus a minus 3. Since I factored the 2 out, what I'd like to do is I'd like to look at what's left over. And looking at what's left over, that shows me that it is a trinomial, and it's a trinomial that has a coefficient that is not 1. Let's go back and look at our notes. This is the exact problem that we did earlier. 4a squared plus a minus 3. We had to use slide and divide on this one so that we actually could factor it. It wound up factoring into 4a minus 3 and a plus 1. So if that's the case, I know that once I do slide and divide, I'm going to wind up with 4a minus 3 and a plus 1. The 2 that I factored out at the beginning just tacks on, and it continues to be part of my answer. I just leave it there in front of my first binomial as my coefficient. So that 2 continues to be part of my final answer as another factor. Let's look at a few more. Number 5, also a trinomial, and if we look at the first term, there is a 1 in front of that x squared. We do not have a GCF, so I can go straight into trying to factor it with one of the methods that we discussed earlier. Since the a value is 1 and it's a trinomial, we will use just reverse FOIL. Reverse FOIL thinking first times first makes x squared, so x times x makes x squared. What two numbers multiply to make 7 and add to 3? All right, well 7, I get 7 by 1 times 7. 7's a prime number, so that is actually the only possible two factors that I can use to make 7 is 1 times 7. Is there any way that I can add 7 and 1 to make the 3 in the middle? No. If that's the case, I have thought of every possibility and I cannot make these factors work the way I want them to, then this comes out to be prime. I have tried the methods that I know how to use. I have exhausted my options, and I do not have a possible set of factors that will work. Let's try one more together. Let me find a good one. Let's look at number 6 and 7 here. Number 6 looks like a difference, and they are 2 cubes. So since it is a difference of 2 cubes and my bases are a and b, I do not have a greatest common factor, so I can just use the difference of cubes. So I start with b minus a, and then I take my first one, which is b squared, opposite sign, b times a, positive sign, a squared. For the last one, h squared plus 49, h squared is a square, 49 is a perfect square because 7 times 7 makes 49. So this is a sum of squares. And if you guys look back at your notes, we said a sum of squares is the one that is prime. So this one is prime as well. All right, thanks guys, time to practice.